Okay, so question number 6. What is the Lewis structure of iodine trifluoride? So first let's find the total valence electrons in the structure. So in the case of iodine, there are 7 valence electrons. And for fluorine, there are also 7, but we have 3 fluorine atoms, so we take that into account as well. And we have a total number of 28. So now I'll draw my iodine with my 3 fluorines all around it. And I'll draw out all the lone pairs as well. So if we count out how many electrons I've drawn so far, each bond contains 2 bonding electrons, and then we have 6 in total for each fluorine atom, so I only have 24 electrons drawn. So for the remaining 4, I'm going to add them as lone pairs around the iodine. Now we're left with the following Lewis structure. Okay, so let's see what the junior tutor said. A Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes radicals. Drawing the Lewis structure of a compound may sometimes need some trial and error, however, we can follow some guides and rules in drawing it. Okay, so step by step, determine the central atom. Typically, the central atom can create the most bonds. Sometimes it is given in the formula of the compound itself. Step 2 is to logically arrange the atoms. Thinking beforehand how many bonds an atom can create can be helpful. For atoms that follow the octet rule, the number of bonds an atom typically makes can be solved by subtracting 8 by the number of valence electrons of an atom. And step 3, connect, adjust the number of bonds if necessary, and check the rules if they're followed, redraw the entire molecule if needed. Okay, so let's skip down to when they answer the question, only iodine can exhibit expanded octet. Therefore, it is the most logical central atom because it can create the most bonds. 2. The skeletal structure would simply be an iodine atom in the center that is surrounded by the 3 fluorine atoms. Step 3. Since fluorine follows the octet rule, it would typically create a single bond only. The remaining valence electrons will be represented as lone pairs. Since there are 3 fluorine atoms, 3 valence electrons of iodine will be used to create 3 bonds. As a result, the remaining 4 valence electrons will be drawn as 2 lone pairs, and they got the following structure. Okay, so lastly, they calculate formal charge, which is also a good practice as well. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons plus or also minus the bonding electrons in the molecule divided by 2. So rule 3, all formal charges are 0. So this solution is correct.